My name is Philip Dawn. I'm the project manager of Synonym Systems. We're a startup company that specializes in producing embedded solutions to telecommunications problems. I'd like to introduce our team, starting with Ryan Dale, our hardware engineer, Michael Berglund, our communications engineer, and Jeremy Hartzell, who is our software engineer. We're advised by Professor George Wright from Texas A&M University, who brings a great amount of experience to our project in the area of embedded systems, as that is his area of focus at A&M. Our current project is sponsored by Network USA, which is a telecommunications service provider spread throughout Texas, Louisiana, and Mississippi. This geographical diversity has led to certain challenges for Network USA related to data gathering of their network equipment, as well as having control and managing this equipment. The typical solution one would use for managing a network remotely is the Simple Network Management Protocol, or SMP. However, not all of Network USA's equipment supports this protocol. What this means is that maintaining an operations, administration, and management system is impractical in their current state. This little animation will demonstrate they have some equipment up top which they can configure remotely from their user console. However, they have other equipment which cannot be configured or have data gathered from remotely at this time. Our objective is to deploy a TransHub remote terminal unit to the network locations to translate from SMP into the native command line language of this equipment of interest. This will allow remote status and configuration of this equipment while providing control and status of the environment the network equipment has been located in, such as a door lock being able to be controlled or monitored, or another example would be a generator that can start or stop remotely. You can see that once a TransHub has been placed in their network, they will be able to use SNMP to gather data on all of their equipment in the same manner and collect that data into a central server. This project is justified because it will reduce their cost in several areas. It will decrease the cost related to associated with getting their engineers and technicians on site to configure or monitor their equipment, and it will also reduce the cost of paying the engineers while they are traveling there to do that. It will also reduce their response time whenever a situation emerges that needs their attention. It will also increase the visibility of their equipment from their central office, so they're always aware of what's going on with their network equipment. It will increase their ability to monitor both the locations and the network equipment itself, and it will provide remote control of the locations. We're going to bridge into project design, and I'm going to start by discussing the problem statement Network USA has approached us with. They have perused the market looking for a remote terminal unit that can achieve these goals for them. However, they have not found an RTU that has the features they desire at a price they can afford. As the network equipment that does not support SNMP appears to be meeting their needs in other areas, the only complaint they have is that it does not support Simple Network Management Protocol, so it would be far too expensive to replace this equipment for this reason. The solution we are presenting to Network USA is to design a new remote terminal unit, the TransHub, that will fit their needs, provide the features they desire, and fit their budget. I'm going to hand it to our hardware engineer, Ryan Dale, to take it from here.
All right, thank you, Mr. Dahl. I'm going to be going over the functional requirements with you guys this morning. Start off, the first functional requirement we put together by being in communication with Network USA has been the translation of these protocols to legacy protocols. Next is going to be configuration of the TransHub RTU, both locally and remotely. Second is going to be a command line proxy using the Telnet session. Followed by that, alarm monitoring, and a minimum of 6 serial port connections on the TransHub device. There will also be general input and output for environmental control of that remote site, as well as modularity to the TransHub device. Let's look a little bit further into these requirements. Once again, we're going to be focusing primarily on the translation from simple network management protocol to the legacy protocols such as TL1 for the legacy devices. The configuration will also be available for local and remote using a telnet session. This telnet session will also provide proxies to the remote equipment using that TL1 protocol as well. The TransHub will require 6 legacy equipment connections that will be RS-232 connections for connection to those legacy devices. In regard to alarm monitoring, this will include checking the status of the network, checking system health, etc. Sensors means the environmental control, making sure that the environment is in control and monitoring those status. The general input and output for the environment would include 32 digital inputs, 8 analog inputs, and 8 digital outputs. This is for the reading and control of the remote site, so that Network USA can monitor such things as temperature, generator control levels, and door status, lock control, etc. The final requirement is going to be modularity to this design. This enables Network USA to add expansions where they seem necessary. Examples of this would be a serial to modem connection or the feature for additional RS-232 ports for the legacy equipment. Moving on to the conceptual diagram. As you can see, currently Network USA has no way to access their legacy networking equipment remotely. And as you can see, once the TransHub is placed at that remote site, Network USA is able to access the legacy networking equipment from their corporate headquarters, as well as the environmental control of door status, generator control, etc. Moving on to the functional block diagram. We chose to use a field programmable gate array for our current design and communications with our processor. The primary reason for this is we did some research looking for microcontrollers with 6 UART ports or more. The prices of these were very high, starting about $3 grand. So the solution we came up with was using a FPGA to use gate logic to create these extra UARTs. This therefore knocks the price down to about $200, $300, therefore saving thousands of dollars for Network USA. To move on, the FPGA will also be able to process those digital inputs for the environmental control as well as the digital outputs. The inputs will require a multiplexing where the outputs will require a deplex. The analog inputs will also be muxed and then converted into digital signals for the processor on board the MCU. Network USA's core network will be plugged into the TransHub via Ethernet port, which will be run to the processor, and a USB 2.0 port will also come from the processor, allowing for a backup connection. To expand more, there will be a second Ethernet port on the TransHub device. This will allow for local configuration of the TransHub, as well as a PC104 slot. This is a serial bus which allows for very quick expansion